Welcome everyone. This is lecture 50 on a new topic which is Geographical Information System. So this is a very important topic overall, because whatever data you have collected, whatever information you have generated, then this information has to be used together. So in this lecture you will understand that how this GIS could be useful for integrating the entire data sets which you have learned from the different geomatics tools. So let us begin this lecture. What is a GIS? GIS is a term which is called Geographical Information System. In the literature you will find Geographical Information Science also. So this is a special kind of a information system. So when we are talking of the information system, naturally we need some kind of a hardware and the software support, and with the help of this information system, we can carry out some kind of a spatial analysis, and a spatial analysis is what is where. So this is very important for a civil engineer which is dealing with the coordinate system. So what is where on the earth surface, locate everything with the help of the coordinate system on the earth surface. So everything is connected to everything. So that is the concept when we are using the coordinate system to locate anything on the earth surface. So it will also actually encourage the people to think, especially to think in terms of the coordinate systems, or to carry out the analysis which is geographically connected analysis. If we see the GIS technology, we had earlier the digital cartographic technology where the maps or any drawing were cartographically represented in terms of the line, in terms of the point, in terms of the polygon features. Then later on the CAD based software came where we can represent actually those cartography, those drawings, hard copy data into the soft copy drawing. So from digital cartography to CAD systems came where we were representing the maps into the different scale and different themes. Then the database management system also came. So the database management system and the maps which we are integrating together, that is basically the GIS technology. So it has developed from the two things. One is the digital cartography, which is the CAD based technology, and another thing is the database management system. If we integrate that together, that is basically the GIS technology is. Now GIS consists of two things, a database as well as the maps. Database could be numbers, could be the information, like it could be elevation data, it could be the precipitation data, it could be the temperature data, it could be the population data, it could be sea surface temperature, traffic data. So these are all the data, and these data are definable in the space. We can actually represent in terms of the point, line and area feature in the space and connect this data with those features. So GIS, what it is doing, it is carrying out the analysis with that data, carry out the manipulation, carry out the interpolation with that data. The other component, very important part of this, is the maps. So map is the graphical representation of the various objects of the earth surface. So we are representing those features in the form of a graphical representation of point, line or area features present on the earth surface. Natural features, cultural features, we are all showing. So we are preparing thematic maps from the geospatial tools which we have learned in our previous lectures, and these thematic maps now we can use them in GIS. So some maps we can use directly, some maps need little bit of processing, conversion in order to use into the GIS environment directly. If we look at the database, it is like a table, as we are using the Excel software or any other Oracle or any other software, database software. So it is a tabular data. It has lots of columns and it has a lot of lines. You can add certain columns, you can add certain lines, so you can make it very exhaustive data. So when in GIS we are using very large number of data files, then this data set is very exhaustive, and when the data set is very exhaustive, then difficult to interpret. It is not very easy. You cannot extract the information, you cannot do the data mining from this data set so easily. So, you cannot see any pattern, you cannot visualize any correlationship from this data set. So, this is simply a raw data which has been represented in the form of the database. So, it at times very difficult actually to understand the huge data, to understand the pattern, to understand the relationship, to understand the correlation between the data. But if the same data is categorized and shown in the form of the map. So, this is the map visualization of the data in the form of the map, and different data sets have been categorized and different colors are those categories. So, you can see the blue color, you can see the orange color, you can see the coffee color here, and you can see very light brown color, and then the remaining areas. So, if I classify that tabular data into different classes, group each of the data set into one class and show it spatially in the form of the map. So, this is called the visualization of the data, graphical information. So, then it is easily understood. Now, I can visualize the pattern, I can see the relationship very easily. So, I can see that there is a blue color which is indicating some classes is present on the northern side of the area, things like that, correlations between the all. So, it is very easy to understand, and it is worth of the 1000 words. So, instead of saying 1000 words, we just show the map and it conveys the meaning. Now, this geographical data or the information which is with us in the GIS mode, what is that? This is the information about the places on the earth surface. So, it could be information related to the location, it could be information related to the name of the place, related to the conditions, etc. Knowledge about where something is situated. So, that is very important nowadays, that where what is located. So, that kind of a knowledge is important to us in many application, in many business platform. Knowledge about what is given at a location. So, what is present at a given location. So, if I know the location, I like to know what are the features present, what are the objects present at that particular location, what is the land use at that particular point. So, this is also important. What then can be very detailed or very coarse information. So, either we may have a fourth level of information which we can get, let us say, from 1:1000 maps, or we can have information, broad information, like we can get as the 1:1,000,000 scale map. Can be relatively static information or rapidly changing information. So, we may have one time information, or we may have the change with respect to time, rapidly changing information, temporal data information. It could be sparse or it could be a voluminous. So, we have a sparse data like rainfall data from rain gauge station, that is a very sparse data, or it could be a voluminous data. So, suppose we have the data about each and every house. So, this becomes the cluster of the data, the voluminous data. So, data has a different kind of a shape and different kind of a way to classify into different ways. Now, why GIS? GIS matters a lot. These are the information systems. This will keep the track of my maps and the data and the events which I am showing there, activities which are related to that, things which are related to the earth surface, but also where these events, activities are happening. So, it will tell me two things now, the activities or things which are happening, where these are happening, and keeping a track of that, monitoring of that particular area. This location, geographical location which we are dealing in the GIS is very important attribute nowadays. Whether we are talking of making some policies, devising some strategies, or making certain plans. So, the location is very important, for which location, for what area we are actually doing that activity. Identifying the geographical problems. So, it relates with the location again. So, identifying the geographical problems in the entire area, because the problem might exist in a certain area, and there are certain areas which requires more attention than the other area. So, what are those geographical problems in a particular area which could be different from the other areas? Now, when we are talking of the GIS, almost everything happens somewhere in most of the cases. So, anything which is happening, it is happening somewhere on the earth surface. That means it is related to its coordinate systems. So, knowing where something has happened is very important for all of us, and that is how the GIS will provide you that information, that what is happening where, and its monitoring. So, if we want to, let us say, we want the position of the boundaries, location of the boundary, country boundary, cross country boundaries, we want the location of the hospitals in our applications, we want to route the vehicle to the shortest route, we want to carry out the management of the forest fire, and we like to determine the extent of the fire, we want to monitor the urban growth and provide the check on the urban growth. So, all that is requiring the application of the GIS. So, GIS is very important in order to determine the where and what is happening where. Now, this technology, GIS technology, is consisting of the hardware and the software tools. So, basically two broad things are there. We have a hardware system and we have a specific software system which we use to carry out the analysis of the data. So, it will handle the geographical information which we are collecting and creating some graphical data, creating the database, the information, to store the data, to classify the data, to carry out the manipulation from the data, to update the data, and to create the output from the data. So, we can do lot of things actually from that data or the information which we are collecting for the GIS. It is a fundamental tool which we are using actually to convey the information through the mapping. So, lot of information is converted into the geospatial based maps data, and this is a very useful tool when we want to convert any point data and we want to show in the form of the map, any line data in the form of the map. So, it is helping us in overall decision making process, and because of that the many administrators and planners who are actually maintaining the database of the activities connected with their organization and using this particular database to help them in taking the decisions. Now, if we look at the definition of the GIS, this is a computer based system. Obviously, the base is like a computer based system which can carry lot of things now. The activities are capturing the data, storing that particular data, checking the data, integrating the data, carry out the manipulation from the data or interpolation from the data, then carry out the analysis of the data, and finally displaying the output. And all this data is geographically referenced data, especially referenced, geographically referenced. So, you know, the geo-referencing of the data is very important. So, that data has to be geo-referenced so that we can use all the data for various kinds of activities. Now, if you look at this diagram here, down below is the earth surface. So, this is a piece of the earth, and from this piece of the earth several types of layers have been created or the data has been generated. So, it could be data related to road, it could be a data related to land parcel, it could be the land value, it could be the slope, it could be the rainfall in the area, it could be the urbanization. So, lot of information could be collected from same piece of land. So one can see that there are different kind of maps, and in this diagram 6 different maps have been created, and these maps are basically geo-referenced with each other. So you can superimpose them one over the other, and these maps are geo-referenced with respect to the earth surface also. So any pixel on the map will represent the actual geographical location of that pixel on the ground. So we are using actually this set of information to carry out the analysis, to carry out the visualizing of the information, or presenting the spatial data output, or creating some kind of a database for the future use. Now, very simple definition of the GIS which the people who are creating different kind of spatial maps, they say that earlier the maps were shown in a hard copy product. So we had a printout of the map, hard copy product like Survey of India maps. So those were the traditional maps, but when GIS came, that map, if I show that map in a computer, that is called the sample GIS activity. All the maps which are shown in the computer using some capability of the software, they are the GIS map. So I am showing a GIS map on the screen, this is my GIS activity. But what are the smart maps? The smart maps are those maps where I have linked every information to the different points. I have included the information, I have linked the information to point feature, to line feature, to area feature which I am showing on the map. So smart maps are interactive maps. So if you click on a particular location, you will get what is the site number, who is the owner of that particular plot, what is the area of that plot, and so on. So you can get lots of information which have been stored in the GIS database. So smart maps are interactive maps, they are not just the graphical representation, but there is a two-way communication, numerical data is also attached to that. If we look at the history of the computers and then subsequently the GIS based mapping, in post 1960s, the computerized system of cataloging the data and analyzing the data sets came. So we have to catalog the data, because if it is a huge data, then probably the searching from that data was not very easy traditionally. So cataloging was done, and how to analyze the data, including the geographical data which is connected to the location data. Then they are used later on for agency specialized, and they were not widely available later on. The examples are, you can see MIMO, map in and map out in 1959, CGIS, the Canadian GIS which was developed then in 1963, which was the first true GIS package. So this was called CGIS, Canadian GIS package. It has certain capabilities beyond the normal showing the data. So it has the capability of making the certain query, carrying out certain spatial analysis. Then Harvard Laboratory for Computer Graphics has developed. Then there was a GIRAS, which was Geographical Information Retrieval and Analysis System by USGS, and so on. You can see that till 1970s the several GIS based modules, software have been developed because of the obvious advantage over the normal cartographic software, the normal CAD software. Then if we see the period of late 70s and early 1980s, then there were software which were integrated software, or they were commercially available packages were available. MacDAS in 1973, then the ERDAS came in 1978 by Leica Geosystems. Then we have the ArcInfo by ISRI India in 1981-82. Then the GRASS, which is the open source software by US Army Corps of Engineers in 1982. MapInfo, IDRISI. So this is a quite long list is there, but this is the exemplary list is shown that between 70s and 80s lot of developments have taken place and lot of software have come which were internationally available to the user community, and the user community was able to handle the large amount of data set and carry out the spatial modeling in the data set. Now if we see the current push is more toward the open source GIS platform. So we have the open source GIS platform, we can adopt the standard data format. So it is toward the standardization of the data format and using some kind of a open source GIS platforms came later on, like OpenGIS, Quantum GIS, UDIG, GeoServer, MapServer, Degree, and then ISO, OGS standards, PostgreSQL, PostGIS data, and so on. So this is the kind of the development which has taken place from the very expensive kind of a commercially available software to the open source software. Then if we look at the history of computer and creating a spatial map or creating the analysis from the spatial map, the John Snow, Dr. John Snow, who is known as the father of modern epidemiology, is also known as the father of GIS because he was the first person to represent the data of the cholera in the form of a spatial map. There was a cholera outbreak in the London Broad Street, and then this was to be shown geographically in the form of the map, and later on due to the geographical location it could be correlated with the other things like the hand pumps in the area. So Dr. Snow, who was a medical doctor, actually tried to map those locations where there was a lot of cholera death actually has taken place in 1854. So those plus are those locations of the cholera death which has taken place, and then he tried to superimpose the water pumps, hand water pumps location of that, and try to find out the correlationship that probably there is a correlation between the number of death and the water pump locations, and he could locate that probably the water was the main reason because of lot of death was taken because there was pollution in the underground water. So geographically the things could be correlated when several information were overlaid, then the corrective measures were taken. So this was a very important study, and first use of GIS was done there, practical applications. So GIS can handle the spatial information which is related to the geographical locations by its XY coordinate, by its latitude and longitude, and then these information is connected to each other. So one information or the one data is connected to the other data with the help of these coordinate system. You can establish the connectivity between the different data sets together. So spatial data is spatial to us because almost all the human activities and decisions nowadays dealing with the earth surface, they involve a geographical component. So we take any planning activity on the surface, it has a geographical component. So it is defined in terms of the areas, in terms of the coordinate systems, and this geographical information is spatial because it is a multidimensional information. At least we define at least a point information by its two coordinate systems. It is voluminous information. This information can be used for taking the measurements. If I know the coordinate of the 2 points, I can get the distance, for example. We can use it for analysis purpose. So lot of analysis could be done with the information which is the geographical information. Now there are different source of data, GIS data sets. So I can get information to my GIS system from different tools and different sources. And many of these tools and many of these sources you have already learned in this geomatics course also. So, we may have, for example, digital maps already available in the digital form, like you can get topographical maps in the form of the digital data from Survey of India. Then there are satellite images and there are photographs which are available in the digital mode. There are attribute data tables available. Then there could be field data which you are collecting from the different modern devices which are giving you digital output. There could be transformed maps, there could be data from the GPS. So, there are lot of sources from where we can get the data, input data into the GIS. So, once the data is input to the GIS system from these sources, we have to ensure that this is geographically referenced to a common datum, to a common reference system, so that the integration becomes easy. Also, we have to ensure the accuracy part of it, that what is the accuracy or inaccuracies which are present in these different data sets, because they have been collected from the different tools and different methods. Now, if we look at the map here, the earlier we had the paper maps and lot of planning was done traditionally on the paper maps. We have to make the alignment of a route, we have to do the all the planning on the paper maps. Then later on, the things became digital in nature and there were tools available to us from which you can collect the data about the land surface and use the instrument like total station or use the instrument like the GPS in order to collect the data of the earth surface in digital form. So, whether it is a point data or line data or the area data, everything can be collected in the digital environment and then it becomes directly input to the GIS. So, in GIS also, when we are using in the computer, we are integrating several data sources together. We were mainly focusing two-dimensional planning. So, our planning was mainly in the two-dimensional environment in the GIS, but today with the modern tools and technology, we can create a 3D model. So, as you have learned that we can use digital elevation model and digital surface model, and the data which you are collecting has 3 components X, Y and Z. So, why not create the terrain model? Why not visualize the entire terrain in the third dimension and carry out the analysis in the third dimension, carry out the planning of the new projects in the third dimension. So, that is the advantage of integrating that all the data into the GIS database. Now, when we are talking of the geographical problems, we have two kinds of geographical problems. One could be the spatial scale, another could be the temporal. So, we are showing actually in a map, there are some areas which have more problems compared to the other areas. For example, they say that particular area requires better roads, more number of roads as compared to area B, or temporal, it could be a temporal scale also, that we can monitor the area at different times of the years and then we can identify which are the problematic areas. So, geographical problems could have two nature, the spatial and the temporal. The examples could be that we want to locate a new highway, we want to carry out the management of the forest or disaster management or the precision agriculture. So, where we need either the spatial scale information or the temporal scale information data. Now, when the information is geospatial in the GIS database, you can carry out a lot of activities, and this could be positioning of the data, calculating the coordinates, you can carry out the mapping from that data, you can carry out the measurement from the data, you can simply use it for visualization purpose, a 2D visualization, 3D visualization and the time frame visualization with respect to the time frame, animations. You can process this information, you can carry out the modeling, different models can be used to integrate the data together and get the output. For example, you can carry out, let us say, the runoff modeling from the rainfall data. Yeah. You can carry out the scanning so that the paper maps could be converted into digital environment, and finally the monitoring of the area. So there are a large number of activities one can carry out once the information is available in the form of the digital. Now there are three types of GIS which are used. There are number of software which are available in the market, ranging from very high powered analytical software to web based software. So you have a web enabled software, and each of the software has its unique purpose, own purpose. Now you have to understand which kind of a software or which kind of a hardware is required. So it is important that we should understand what are the different categories of the GIS available to us. So we have three main categories here. The desktop GIS is there, standalone kind. Then we have the geo browser type and web based GIS. So these are the three broad categories of the GIS systems which are available to us. So let us see one by one them. The desktop GIS will allow you to interactively work with the spatial data. So you have the maps and you have the tabular data. You can interactively work with the desktop GIS software. So it is primarily a mapping software that runs on a personal computer, a standalone computer. You are working on this desktop GIS software and carrying out the analysis. So for example, ArcGIS, which was earlier developed, was a desktop kind of a GIS software. Now network based modules are available of this software. When we are talking of the geo browser software, it is considered as an internet explorer for geographical information. So as internet allows you to use the combination of many types of geographical data from many different sources. So in the geo web browser, the biggest difference between this World Wide Web and geographic web browser is that everything within the latter is spatially georeferenced in the geo web browser. So for example, Google Earth is the best example of the data. So you can actually download the data from the various sites, internet sites, and can use that data directly into your system software. So Google Earth is the most best example where the images are geographically referenced images which are available on this browser. The third category is the web based GIS. So web based GIS are basically the online GIS application, and they are very excellent. They are the excellent tools for visualization of the data. So the functionality is limited as compared to the software which you are storing on the system, but they are very user friendly, the web based GIS, and very useful as they do not require the data to be downloaded. So already they will take the data from the web and you can carry out the kind of the analysis. Now GIS applications, there are large number of applications of the GIS. This is just exemplary list. The utility companies are using, it is used in transportation, it is used various activities of the agriculture, planning on the land surface, forestry application, land use, land cover mapping, or any kind of a disasters mapping and management, urban monitoring, 3D modeling part. So this is only the exemplary list here. Applications are much more beyond that. So when we see this list, we find that there are almost everywhere in every domain area, wherever the land is involved, whereas the earth surface is involved, it has the application. Now there are additional users of the GIS activities, and they are the archaeologists, architect, planners, geographers, computer scientists, IT specialists. In medical science, the doctors are using, engineers, historians, politicians, statisticians, meteorologists, they are all using the GIS in order to link the database with the spatial maps. So, the data can be converted into the spatial maps and can be used to study the geographical patterns, can be used to see the relationships between the previous data and then probably interpolate that relationship in order to do the predictions. So, one can carry out the analysis of the previous data in order to predict the uh, pattern in the future. Now, there are many commercial companies also which are using, like property developers to sell their properties, different organizations, different ministries, law enforcement agencies, police, military. So, these are few agencies which have been named where GIS is being used. There are very large number of government projects, big projects like the smart city projects or like the interlinking of the rivers. Those bigger projects, they are compulsorily using the capabilities of the GIS, and geospatial data is playing very important role in this project. So, if you look at the overall domain area where GIS can be applied, in fact today it is applied almost in every sphere, in every field. So, this is kind of a multidisciplinary, its nature is multidisciplinary. So, one can see that you require not only the civil engineer, not only the people who knows the geomatics engineering or surveying, but database specialists are required because it deals with the database and then relational database and the management of this database. Then CAD based design is required. Then people with the digital mapping, photogrammetry, surveying, remote sensing and so on and so on. And this circle may increase, it depends upon the application part also. So, this is broadly indicating that GIS is a multidisciplinary field. It is an area which could be applied to a large number of disciplines together. Now, knowledge based for the GIS, knowledge based for the GIS can be actually created by the geography and related cartography, statistics, remote sensing data. Then computer science and IT people will have the programming part, the graphics part of it, the visualization, the data management aspect, the security aspects of the data management when it is on the open platform, and then there are several application areas. So, application could be in different fields, and if we are applying suppose in power sector, then probably we need some kind of a expertise, some kind of a knowledge to be transformed from the electrical engineers. So, there are application areas. So, this is the knowledge base which has to be created by the convergence of the various technological fields and various disciplines, and everything will come to the central place, the GIS, where this tool could be used to carry out the analysis of the information. So, this is all about my lecture. Thank you very much.